Today's lesson is an extension of what we did yesterday, so the problems will just be a little bit tougher. There'll be another one of these projectile problems as well that we'll be continuing to work on, and so let's take a look at these problems. So they ask us to solve quadratic equations by factoring, and then we're going to check our answer as well. So the first thing to do is to draw two sets of parentheses and factor away. So we've got this already set equal to 0, which is important. We want it set equal to 0. If it wasn't, then we'd have to set it equal to 0 first. So I go ahead and factor, and I see the numbers need to multiply to make 18, but subtract to make 1. And since they make a negative 18, I'm going to use negative 18 and a positive 1. Well, once we get the factored form, then we're setting the factors equal to 0. And so remember, you've got two of them. There's two different factors, and we set them both equal to 0 to find out what the two values are of x that make 0. When we go ahead and multiply the two factors. So one of them is going to end up being 18. So if you put 18 right here, and this is checking your work, just substitute that 18 back in for x. And you can do that in your head. See, 18 minus 18 makes 0. 0 times any number just makes 0. So that's one of the answers. Over here, we're going to take away 1, and we end up with x equals negative 1. Put the negative 1 right in for this x. Negative 1 plus 1 makes 0. 0 times any number just makes 0. So those are the two solutions, negative 1 and 18. So we'll put them in a brace to represent a solution set. So there it is. Well, in this one we have to move some terms around first, and that's what we're going to do here. We're going to go ahead and move this 19x and this 42 over to the other side. So whenever you move a term, you see you're going to do an opposite operation. So I'm going to subtract 42 from both sides, subtract the negative 19x. So you're going to end up with an equation with the terms with different signs. So that's all that happens when you move a term over. It just switches signs. And so then from that point, all we're going to do is factor. This one seems kind of tough because what numbers multiply to make 42 but subtract to make 19? Well, take 42, and if you don't know other factors, break it down to 6 and 7. Then take the 6 and break it down and maybe group like the 3 and the 7 together. That makes 21. And so let's try that. 21 and 2 multiply to make 42. And if I subtract those, I can get negative 19 if I put the negative sign with the 21, the plus sign with the 2. So from that point, I go ahead and set those factors equal to 0 and then solve. And so when I do that, come up with my two answers here. I got to add 21 to both sides. On the other side, I'm going to subtract the 2, and I end up with x equals 21 and x equals negative 2. And if you look at it, again, check your answer. Plug the 21 back in for x. It should make 0, which it does. Negative 2 in for this x will make 0 here. Either way you do it, 0 times whatever number it is still makes 0. So those are the right answers. Negative 2 and 21. That's our solution set. Remember, these solutions represent x-intercepts because we're setting y equal to 0. That's what the 0 is. Over here, we just got to move this 28 over. Remember, you're adding it to both sides. So I'll add it to both sides. And so you see when you move something from one side to the other, it just switches signs. So let's rewrite what we've got. X squared plus 11x plus 28 now equals 0. So you go ahead and draw the two parentheses, and it's going to be x plus 7 and an x plus 4. 4 times 7 makes 28, and they add to make 11. You set those factors equal to 0, and you solve for the unknown. So you can probably do that work in your head again. It goes pretty quick, as long as you're careful. You subtract 7, you just move it to the other side, and you get your answer. X equals negative 7. And also x equals negative 4. You plug those numbers back in, just check. Negative 7 plus 7 makes 0. Negative 4 plus 4 makes 0, so they both work. Negative 7 and negative 4 are the solutions. Well, over on this next one, again, you're just moving that 4 over to the other side. We got 3x squared minus x minus 4 equals 0. So when I go ahead and factor this one, I'm going to start with the 3x and the x that multiply to make 3x squared. Now I want the numbers to subtract to make negative 1, the outside terms and inside terms. So if we use 4 and 1 like this, you'll see how it works. So you got 4x and 3x, and yes, we can make a negative 1x if we put the minus sign with the 4, plus sign with the 3. So we know we've got the factoring right, so you're ready to set the factors equal to 0. So again, you're just doing the 3x minus 4 equals 0, so you have to add the 4 to both sides. So you're left with 3x equals 4. Divide by 3. See, I'll show that work here. Divide by 3. You've got yourself a fraction. X is 4/3. Leave it just like that for now. Well, the next one, we're going to end up having to do one less step. You see, it's just x plus 1 equals 0, so you just need to move that 1 over, so it makes negative 1. So we get our answers of 4/3 and negative 1. Well, we're going to see the same situation with this next one. See, over here we've got a 2x squared, and this one's all set up for us, so we'll go ahead and draw the 2 parentheses there. 2x, and x makes 2x squared. Numbers that multiply to make 5, but remember this time they're subtracting to make 9. So I'm going to put the 5 here and the 1 here. And you see it works, because this is 10x, and this is 1x. We can get those to subtract to make 9x. We want a negative 9, so we make it a negative 10 and a positive 1. Well, from that point, all you're going to do is set the factors. The 2x plus 1, set that equal to 0, and do the same thing with the x minus 5, set that equal to 0. So when you do the work, you end up having to subtract the 1 from both sides. So you're left with a 2x equals negative 1, and then divide by 2. So when you divide by 2, you see, I'll show that right there, you end up with a fraction. X equals negative 1/2. And so from that point, we can just move this 5 over by adding it to both sides, and we have x equals 5. So there it is, negative 1/2 and 5 are the two x-intercepts. Well, taking a look at the next one, we've got ourselves a plus sign for the last term. And notice that this is a perfect square and this is a perfect square. So what I'm going to do, my first attempt at this, since I have two perfect squares, is to think of this as a trinomial square. So 2x and 2x make the 4x squared. 3 and 3 make 9. I'm going to put plus signs in there. Just got to check the outside terms and the inside terms to see if they make 12x. 6x and 6x, yes. It does end up working. It makes 12x. So I know I've got it right. And so here, since they're the same exact binomial, you're only going to have one answer. You don't have to write that one answer twice. Some people will do that. You don't need to do that. Just write it one time. It's the same number. It doesn't matter what that number is. It's still the same. So 2x equals negative 3 divided by 2. It's a fraction. X is negative 3/2. And there's your answer. So here we just have one solution. It means the vertex is right on that x-axis. And there it is. Well, here's another one of those projectile problems. So it's good to understand where we use this. And oftentimes we use quadratics to solve projectile problems, or any type of problem that deals with anything that has an initial velocity, and then after that initial velocity, acceleration of gravity is just pulling it back down to Earth. So here it is. The height of a rock thrown off a cliff can be modeled by this equation. So what this tells us is that the cliff was 120 feet above the surface, whatever the surface was, like water or earth or wherever it was. And its initial velocity was this, well, -8, and so it's really 8 feet per second. And this -16 deals with the acceleration of gravity. It's just half of the acceleration of gravity when the acceleration of gravity is in feet per second squared. So what we're going to do is we're going to model this, and I'm just going to draw a little picture about what's going on here. Here's my cliff, and the rock gets thrown up into the air, and then it comes back down, and what they want to know is how long does it take it to reach the ground. I'm going to call this the ground right here. So there's my ground. So when will it reach this point right here? That's what I want to find out. Well, that's the same thing as like the x-axis. We want to solve for x, for the x-intercept, when our cliff, here is our cliff, and that's the y-axis. So we want to know when is this going to end up hitting the ground, which is our x-intercept. Now we're going to end up coming up with two answers. The reason is that this is a parabola. And since it's an upside-down parabola, the vertex is not on the x-axis. That means it'll end up crossing it twice. across this point and this point. However, right here, this point is where the time is 0. So over here, this is like before it was thrown, before the actual rock was thrown. And this is after it was thrown. So all we really care about is what is in pink here. And that's going to be our only answer. So we're going to end up with one answer that won't make sense. And we'll talk about that once we get to our answer. So here's what we're going to do. We want to set our height equal to 0. So that's what we're going to do here. We're going to set this h equal to 0 and then try solving. So let's do that first. Negative 16t squared minus 8t and a plus 120. So I'm going to end up setting it equal to 0, and now I'm going to factor out that common factor. So the common factor in this case is a negative 8. Every number can be divided by negative 8. So let's do that. We go ahead and do that. We got 2t, and then minus, actually not minus anymore, plus t, actually 2t squared, I forgot the t squared there. So 2t squared plus t, because the signs switch, here it makes a minus 15 is what we get when we divide 8 into 120. All right, now the factoring is much easier. So that's why you always want to take out common factors, is because the problem will be a whole lot easier at the end. So when I go ahead and do the work, I got 2t and t. Now I want them to subtract to make t. I want the outside and inside terms to do that, to make 1t. So I'm going to break the 15 down to 3 and 5, put the 3 here, 5 here, and this should work. So here we have 5t. And here we have 6t, and yes, those will subtract to make the 1t. It works. So now what we want to do is figure out the sign. So in order to make a positive, I need more positives than negatives. So the plus sign goes here, and negative sign goes here. So now once we have the factoring done, we just take those factors. Now, anything with a t in it, because that's what we're trying to solve for. This factor doesn't matter, so we don't have to worry about that. So the 2t minus 5 equals 0, and the t plus 3 equals 0. So go ahead and do the work there. Add the 5. We get 2t equals 5. Divide by 2. And you get yourself a fraction. 5 halves. So that equals 2.5 seconds. Alright, that makes sense. Could be 2.5 seconds. I'd go with that answer. Over here, we have to subtract the 3 from both sides. And we end up with t equals negative 3. Oh, remember we said we'd get something like that? We'd get a positive answer, which we see here. This was 2.5 seconds. And then we also have this negative answer, which we said would be over here. And the reason why we have that is because these graphs are symmetrical. But this part is before that was thrown. So this doesn't really matter. We don't even look at that part of the graph. All we care about is from the point it was thrown until it lands. That's all we care about. So we're going to cross off this answer. This is called an extraneous solution. We don't need that one. All we need is this one here, the actual one, which is 2 and 5/10. So 2.5 seconds was the time it will take for that rock to end up hitting the ground. Well, those are some of the problems you'll end up seeing on tonight's homework. Good luck.